Hi everyone. On the same subset of gas behavior to cover for well control IWCF level 3 and level 4, now we're going to look at what happened in the well bore when a kick is taken unknownly and how gas behaves differently in oil-based mud and water-based mud. Let's dive in. The information given here is while you're drilling with oil-based mud and a kick has occurred unknownly, you don't know when the kick was happened. So the well is not shut in, the driller keeps circulating as usual. And what will happen then? Let's look at the simulation here. Gas travels up to the bubble point, breaks out from the mud, keeps going up to the surface and unloading the annulus quickly, and the peak gain is tremendously. We know that the mud is oil-based mud, and we also know that the gas disperses and dissolves into oil-based mud. Therefore, it's very hard to detect peak gain initially. Therefore, it is less chance to exceed mass at the shoe, and therefore the casing pressure will be also lower. And as we said, the gas stays dispersed in mud until it reaches the bubble point. From that point, bubble point onward, the gas will break out from the oil-based mud. And once it breaks out, it will expand the volume significantly and unload the annulus quickly. So from the bubble point onward, you will see the pit gain increasing tremendously, and the volume return is huge. Flow rate return at the flow line is also increased quickly as well. So that will cause, because of that unloading in the annulus after the bubble point, that will cause the loss of hydrostatic head in the annulus. In turn, the well will become more under balance, and therefore you will invite more influx, more gas will come in at the bottom of the hole. So that's how gas behaves in oil-based mud. Therefore, it's vital to detect the kick early, especially gas kick early in oil-based mud. The best practice is fingerprint every connection if you're drilling HPHT well with oil-based mud. And in the event of gas breaking out, what's the chain of action you should take? You need to shut the BOP in to isolate the well, shut it in so that you don't get more influx. Then you circulate the annulus up through the choke. If gas breaks out above BOP for the subsea well, then you activate diverter to divert the gas away from the rig floor. Now come to the water-based mud well. The same thing, you take the gas kick. For example, you didn't know, right? It's hard not to know, but now you didn't know. And the gas came in, right? And when you still don't shut the well in, you circulate, the gas goes up to surface. When it's near the surface, it will unload the annulus quickly, right? But the return is not as much as in the oil-based mud. You see here the pit gain, you have pit gain, but not as huge as in oil-based mud. The gas does expand, but not as much as in oil-based mud. So how are we going to explain for that one then? We know gas and water don't mix together, they stay in separate phases. So at initial kick, you will see the pit gain is apparent, you will notice it right away. And then you circulate the gas, travels up in the annulus, and it expands as it travels up, but not as much as in oil-based mud. So when it's very near to the surface, it unloads, and then you will see the well bore, the annulus unloading more, more than before, but not as much as in oil-based mud. Because of these features, you will have more high chance to approximate or exceed the well mass at the shoe and may break the shoe. And casing pressure will also higher than in the oil-based mud. So to summarize the behavior of gas in oil-based mud and water-based mud, this is what we have. We have the red line for water-based and the black line for the oil-based. So initially, when the gas is still in formation, there's not much to say. But once you have the kick after this first red line here, you will notice pit gain and increment in flow line return on the red line here for water-based mud. Apparently, you will see it. But in oil-based mud, you don't see it because gas disperses and dissolves in the mud. You keep circulating, gas travels up in the annulus until it reaches bubble point, it breaks down. Then you see unloading. Volume in pit gain increasing significantly, and the flow rate return also increase tremendously. But in water-based mud, the red line here, you see the gradual increment of both pit gain and flow rate return. So after all the gas has been liberated from the mud, it's the same for both water-based mud and oil-based mud. That the annulus is unloading and the flow rate return is high. All right, but this one, gas is only at surface already. So that's it. That should cover for gas behaviors in both oil-based mud and water-based mud. I hope you get some useful information. Any comments or questions, just drop me a note at my email address as shown here. And I'll see you soon in other questions for other topics. This should be enough for the gas. Cheers.